Hello everyone. In the last lecture, we have studied about coefficient of adhesion. It can be denoted using capital C and capital A or mu small a. So this is an important factor in the traction technology. And we have also studied about the coefficient of adhesion is nothing but the maximum tractive effort applied to the wheel of the train without making it slip divided by weight on driving axle. In the last class, I have taught this topic, but I skipped some important concept, that is on which factors the coefficient of adhesion depend. So the first factor on which coefficient of adhesion is depend, that is called type of surface of contact. As we know that this is rail and this is the wheel. So this is actually the point of contact, and we have to think what is the surface type, whether it is actually slippery or frictionless or higher friction. So depending upon the friction, the coefficient of adhesion changes. And the second one is speed of vehicle. As the train speed depend upon the speed of the motor, and we need to know what are the speed torque characteristics of that motor. So the coefficient of adhesion is also depend upon speed versus torque characteristic of the motor, right? The fourth one is the connection of motor. This is important concept. According to the electrical supply connection, the coefficient of adhesion is also depend. And the fifth one is type of power modulator. The power modulator are nothing but the power electronics device which actually provides supply, control supply to each driving axle of motor. And this power modulator actually provide electrical supply or control electrical supply to the motors which actually control the driving axle. So depending upon the power modulator, this coefficient of adhesion is also depend. Let us study the duty cycle of traction drive. This is a very important concept in case of traction device or traction chapter. You should know about the acceleration, deceleration, free running, coasting, and all those things. That means when a train or when a rail is starting from one station and reaching to another station, how the speed catches by the train and how they apply the brake and what is the free running condition, all those things we study about the duty cycle of traction drive. That means what is the cyclic formation of the speed, torque and power with respect to time and distance, that can be explained using duty cycle of traction drive. So this duty cycle can be of three curves. The first one is speed, second one is torque, and the third one is power. Okay, the first curve represents speed versus time, second also torque versus time, and the third one also power versus time. Okay, so we'll going to see three different curves which are speed versus time, torque versus time, and power versus time. And after looking to these three curves and after designing these three curves, you can able to understand what are actually the duty cycle of traction drive, right? Okay, let us consider this is a level track. Level tracks means there should not be any inclination. Let us consider a train is traveling in a level track from one station to another station, right? And it takes some time. Power, P is equal to tau omega. That means power is equal to torque with speed. This is angular speed, but somehow it relates with speed. Okay, that is in RPM. And this is my torque. Okay, this is my electrical power. Consider this is my curve. And in this curve, this x-axis represent the time axis and the y-axis represent the speed axis. Okay, so time and speed. And let us consider here at station 1, the train is going to start. That means here the speed is 0, n is equal to 0, and we have a torque. Okay, what is the torque? When train speed is 0, we have to pull and push the train with heavy torque. That means the motor can give maximum torque to accelerate the train from 0 speed to certain speed. That means at time t is equal to 0, speed is 0, and with maximum torque. Okay, the maximum possible torque by the drive which is connected to the driving axle, you have to apply that much torque, and with that maximum torque we need to make the train to accelerate. Okay, and now my train is getting accelerated. Here you can see torque is maximum, that means torque is constant. If torque is constant and I am making the train to accelerate, that means omega is changing, omega increases. So this is called acceleration, and that time you can see power is changing, right? So this part is called acceleration. This part is acceleration time with constant torque. Okay, so with constant torque the train is accelerated. Okay, and the train travel to move from here to here, and when it reaches here at time is equal to t1. Okay, that means here we can, at the time of train starting we need maximum torque, but when the train is getting some speed, that time we have to give maximum power electrical drive to conduct a smooth operation. So here what do we do? Instead of giving maximum torque, we actually give maximum power. Okay, that is why we get a bend in this curve, that up to t time is equal to t2 we are providing maximum power. You can say from this to this is called maximum power region. With respect to time, my speed also increases. So here also we are getting acceleration. Okay, so it is very clear that from t is equal to 0 to t is equal to t1, I am getting acceleration where torque is constant, and from time t is equal to t1 to t2, I am also getting acceleration, but here power is constant. Okay, now the train is getting maximum speed. That means train cannot be go beyond that speed. So here my omega becomes constant. Okay, so when omega become constant, here I am already giving power constant, so torque also remain constant to some value. Yes or no? Yes. That is called free running. So from here to here, right, this is called free running, and this free running condition, speed is constant. Okay, speed is constant. So our time is equal to t3. What do we do actually? We remove the power supply. As my power supply removed, that means there is no input electrical power to the electrical drive. Still the motor rotate due to the inertia of the train. So this portion is called costing. So in costing, there is no electrical power supply, and the train actually move from one place to another place due to the inertia of the train. So it reaches actually time t is equal to t4. Okay, and with respect to the speed, the locopilot is actually applying the mechanical brake here at t is equal to t4. So after applying the mechanical brake, it takes some time to reach in the station. That is called stopping or braking. Right? This braking may be of electrical braking or mechanical braking, or both electrical and mechanical braking. So when we study about the braking, we can study about the types of braking. Okay, so here you can see, as my x-axis represents speed and y-axis represents time, so the curve, the area under the curve is nothing but the distance. Distance is equal to the area under curve. Right? So as my area under the curve increases, so the distance increases. So this is nothing but my speed versus time characteristics or duty cycle of speed time. So this consists of, first is acceleration with constant torque, second is also acceleration with constant power, third is free running, fourth is gusting, then fifth is braking or stopping. These five things constitute the duty cycle of traction drive. What happens sometimes with respect to nearby stations or last station or acceleration or deceleration, some concept may be removed. We will study it later. So for the duty cycle of traction, I told about the combination of three different curves, which is speed versus time, torque versus time, and power versus time. And I also described about the speed time curve. This is this one. So it consists of acceleration with constant torque up to T1, then acceleration with constant power up to T1 to T2, then free running from T1 to T2 to T4. So this free running consists of a small amount of torque and small amount of power. Okay. So here maximum torque, here maximum power, here power requirement reduces and torque requirement also reduces. And here this is ghosting, this is braking. And the torque time curve represent also same thing. What happened from, as I told, from T1 to T2, I have a constant torque. That is why I make the torque line as a constant and maximum. This is maximum. Okay. Then after, my power remain constant. So as my power remain constant, speed increases, and we know power remain constant, speed increases. So my torque has to be decreased. So the torque decreases linearly up to from T1 to T2. Okay. When the torque reaches at T2, I told it is free running condition where we need a little amount of power and little amount of torque. So my torque is further reduces and reaches up to this value. Okay. So this is my less amount of torque requirement. And in costing, I told you costing is nothing but removing the input power supply. So when I remove the power supply, that means my power is equal to 0. So when P is equal to 0, irrespective of the speed, my torque also 0. And when we apply the brake, okay, when I apply the brake, in electrical braking, what we do? We try to make the wheel to rotate in opposite direction. That means we are applying a opposite torque, negative torque. So this is my negative constant torque. So this is nothing but the torque time characteristic of duty cycle of traction drive. And the next one is power time characteristic. Similarly, as this is my constant torque, so power increases linearly. Here from T1 to T2, my power remains constant. So this is a constant power, the maximum constant power. Then in free running condition, I told you less amount of torque needed, less amount of power also needed. So this is a less amount of power characteristic. Then after, in costing, I remove the input supply, so power requirement becomes 0. And in braking, I am getting negative triangle of power curve. And we know that whenever I try to multiply any kind of triangle with a negative constant value, I am getting its mirror image. You try to multiply mathematically, you will find this. So how to do? When a positive wave is multiplied with negative constant value, you are getting its mirror image, downside mirror image. So these three curves indicate the duty cycle of traction drive. And you can see in what is free running condition. Free running condition is that condition where drive torque is equal to load torque. Okay. So when both drive torque is equal to load torque, that is called free running condition. So this is all about the duty cycle of traction drive. So we have studied the duty cycle is consist of, first one is acceleration with constant torque. The second portion is acceleration with constant power. Third one is free running. And the last one is braking. So we can see among these four conditions, These four conditions actually depend upon which kind of train it is and what are the distance between two stop, right? And I told you when the distance is very large from one station to another station, so what it happen? Train takes maximum torque to accelerate, then given maximum power, then free running, then what happen? It actually costing, then braking, right? So this is the actually curve. But what happen if my station, instead of my station is here, let me take a suburban train and here my station is very less distance. We have to apply the brake. We have to apply the brake to stop the train here in this station before the train actually reaches its maximum speed or maximum acceleration. So this acceleration time also changes, right? So depending upon the distance, depending upon the train, depending upon the type of input supply, everything depends. So these all five condition changes. That means let us consider instead of making a level track, let us a train is traveling with an inclined surface. So when it is inclined, what happens? In level track, we are giving maximum torque. Okay, let us consider train is moving in a down gradient. In that time, the acceleration due to gravity takes the train to travel from here to here. So that time we have to apply the brake when the train is in free running condition also. So instead of braking here, we can say braking starts from here. So it depends, but this is the actual concept of a level track. Let us study about the load sharing between the traction motor. Load sharing is actually very important concept. In power system, we have studied the parallel operation of transformer, parallel operation of synchronous generator in the power system. So actually, when all the machine or all the drive are actually running in parallel, which motor will take how much load or which generator or which drive will take how much load, that is a very important concept. If you make two different drive to operate in parallel and one drive is taking the load which is beyond its maximum capacity, so what happens? Obviously that drive will getting damaged. So we have to think before giving the load to the different motor or different drive. So that is called load sharing. Let us consider this is my rail and this is a wheel. Okay, and you know that a locomotive consists of more than one wheel. Yes or no? Let's consider this is my locomotive and you can see many motors are there. So many wheels are there. So among all the wheels, everyone is not driving wheel. Every wheels are not driving wheel or every axles are not driving axle. But some dummy axles are there. D-U-M-M-Y. So dummy means it is actually used to hold the train without driving it. That means electrical motor or driving motor is not connected to those drive or those wheel, that is called dummy wheel. Okay, let us consider this is a wheel or this is a driving wheel, right? And I am having another wheel that is also driving wheel. Okay, in picture I just represent like this. And let us say the radius of first wheel is R1 is equal to 10 inch. Okay, so when this wheel rotate one rotation, that means it travel a distance which is nothing but equal to its circumference or perimeter. Okay, that is equal to 2 pi r. Okay, that means with one rotation of the wheel can travel 2 pi r distance, which is nothing but, so due to braking and running, the thickness of the wheel or radius of the wheel reduces. Let us consider after long running, this radius becomes R2, which is nothing but equal to some 9.998 inch. Okay, a very small amount changes. After the reduction of the wheel radius, after one rotation, this wheel can travel 2 pi r2 distance, which is nothing but 62.819 inch. Clear? That means in a single locomotive, this wheel is available and this wheel is available. And the motor is giving one rotation to this wheel and another motor is also giving one rotation to this wheel. You can see this wheel can travel 62.831 inch and this wheel can travel 62.81 inch. So there is a difference in distance traveled by both the wheel with one rotation. Here in one rotation less high distance, here one rotation less distance. If you make distance same, here you can see this is more speed and this is less speed. So that means what happened? Both the wheel are actually available in the same locomotive and both are operating in different speed. If speed is different, I told you power is given constant, speed is different. So what happened? Torque also changes. So both the motor will not take the same torque, where this will take T1 torque and this will take T2 torque. Okay. So when this condition arises, the power modulator take a vital role to share the torque to different driving axle. So this is the speed torque characteristic of a separately excited motor. Before some time I told you one motor is running with a speed of N1 RPM, another motor is running with a speed of N2 RPM. Take example of one rotation, that means N1 is equal to N2 but distance is different. When you make distance constant, speed changes. So for one motor which is running N1 speed, that will take a torque of T1. And the motor which is running with N2 speed, that will take a torque of T2. We can see maximum speed or higher speed, lower torque, and lower speed, higher torque. This is also described by P is equal to T omega. Right? So by making power constant, so T and omega, or torque and omega having inversal relationship. TR is rated torque. We have two motors. In the example I take two axle. Let us consider both the axle having same radius. That times one axle take TR, so both the axle take 2 TR. So this is the 2 TR is the maximum withstanding torque of two axle drive. But when the radius changes, that means when there is different radius of different wheel, that time the first one take T1 torque and the second one take T2 torque. Let us consider rated torque is nothing but equal to T2. So here you can find TR is equal to T2. That means T1 is less than TR. Okay. And in this condition, maximum torque taken by the drive equal to T1 plus TR, which is actually less than that of 2 TR. Clear? Let me explain you again. When radius 1 is equal to radius 2, that means both the axle having same radius, this axle take TR torque, this axle take another TR torque, so total torque is 2 TR. But when radius is not equal to R2, that time one axle take T1 torque, second axle take 2 T torque, and I consider T2 is equal to rated torque TR. So total it take T1 plus TR, which is less than equal to 2 TR. It is very clear that if the radius of motors are different, it cannot able to take maximum torque or maximum load which can be taken by the motor having same radius. And we can see, instead of making a separately excited DC drive, if I make a series DC motor, and this is the speed torque characteristic of speedy motor, and this is the speed torque characteristic of DC series motor. Here you can see with different two speed, I am getting two different torque, but both the torque are not very far difference, a small difference. So in this case, we can see the series motor will take best load than that of separately excited motor. So this is all about the torque sharing, or this is all about the load sharing of the motors. So you can say the unequal torque distribution can reduce the torque capacity of the drive. It's a very important concept. I repeat, unequal distribution of torque can reduce the maximum torque capacity. Thank you so much.